Introducing the newest way to get around the beautiful city of Baku, our online bike renting app. Say goodbye to long walks and crowded public transportation, and hello to convenient and eco-friendly bike rentals. With just a few taps on your phone, you can easily find and reserve a bike near you, check availability in real time, and pay securely through the app. Our bikes are well maintained and easy to use, making your ride smooth and comfortable. Whether you're a local or a tourist, our bike renting app is the perfect way to explore Baku's streets and sights at your own pace. Download the app today and start pedaling.
Hello, Rosmarin. Welcome to our online bike rental system, where you can easily rent a bike without having to make physical trip to a rental business. And our system provides a practical alternative for the customers who want to rent a bike quickly and efficiently. And our service offers great flexibility to our customers as we allow them to rent a bike for a few hours or even for a longer amount of time. And this gives our customers more choice in terms of the rental duration, which can be beneficial for those who need a bike for a specific period of the time. And we also believe in sustainability, which is why we encourage renting a bike rather than buying one. Renting a bike reduces the demand for a bike production and transportation, making it an environmentally friendly choice. And we take this even further by providing eco-friendly bikes or taking steps to lessen our influence on the environment. Overall, our online bike rental systems aims to provide convenience, flexibility, and sustainability for our customers. Now I want to talk about our requirements, discuss the requirements for the development of online bike system that is tolerate to needs of the Azerbaijani market, and our system must meet certain operational, performance, security, and cultural standards to ensure the effectiveness and acceptance among the local community. And firstly, in terms of the operational requirements, the system must be accessible all time with the minimal downtime for the maintenance. It is also essential that the system has a backup and a uh, recovery plan in the event of the system failure to ensure seamless operation at all times. And secondly, in terms of the performance, the system must be respond quickly and to customer requests to rent the bikes and provide real-time information on bike availability and location. And additionally, it must be able to handle data effectively and efficiently, ensuring that up to 1,000 users can utilize the system simultaneously and without any performance issues. And thirdly, the system must be secure with the safe methods for user authentication and the payment processing to prevent fraud. Only system administration administration should have access to users' account to ensure user information is kept safe and confidential. And the finally, in the system must be designed with the local culture and customs of the Azerbaijan in mind. The system must be available in Azerbaijan language to ensure the accessible to all users, and the payment option must be widely accepted in Azerbaijan, such as bank transfer or mobile payment app. And in conclusion, the requirements are essential for the development of the successful online renting bike system that meets the needs expecting of the Azerbaijani market by alternating alternating to these standards. We can use the system is effective, efficient, secure, and cultural sensitive.
Now I will talk about architecture design. There are numerous technologies that can be utilized in this project, but we selected two of them possible technologies. First one is client-server application. The second one is web server application. The difference is that client server needs to install in client's computer or device. So if we are implementing application, so we are actually implementing application, so that's why we have to use client server application. But for web server, for website, we can use web server application. It is easy. Also, you can reach from all browsers. Here also the recommendation, as we mentioned, the web server application is preferable because no need to install. At the same time, many users can access this application and they can work efficiently.
And now I want to talk about hardware and software specification. And in this chart, you can see our operating system, special software, hardware, and network. For hardware software specification, the standard client operating system should be Windows 11. While the standard web server should be Linux. Linux is a more efficient for the service, for the server side of things. For special software, the client doesn't need anything special, but for a web server, Apache is recommended, while for an application server, Java is recommended, and for a database server, Oracle is recommended, as these programs are standard for all web server and application server and database server. And as for hardware specifications, a standard client should have minimum of 250 gigabyte disk drive and Intel Core i3, the minimum one, and a monitor if not a laptop. And for a standard web server, at least 500 gigabyte disk drive and quad core are recommended for an application server. A 5 gigabyte disk drive, 6 core Xeon, and for a database server, and 8 core Xeon and 1 terrible disk drive, at least with the right for the data storage. And for the network, the standard client should always be on the network to use software, and there may be some performance loss. And for the web server and other servers, at least 100 megapixel Ethernet is there recommended. And and I want to finish my speech here, and thank you for listening. And now my group mates continue the other steps. Thank you.
Today I will be presenting the program design part of our system specification design, and this part includes the final structure chart, which we developed based on our physical data flow diagrams and modified logical DFDs. First, let me explain the process we completed to make the structure chart. We started with logical DFDs, which represent the flow of data and activities in our system at a high level. Then we added some implementation references to the processes, which will show how it will be implemented in code. We also added some human matching boundaries. So we separated the parts of the system that are operated by users or humans from those that are automated. And finally, we add some additional system-related elements, which is like databases, files, and external interfaces to complete the picture. So it's our final structure chart. This diagram shows the actual physical components of our system and how they interact with each other. We identified the inputs, outputs, and processes of each component, and we made sure that each of them matches with the logical DFTs that we modified. So as you can see from the diagram, we add some human matching boundaries around the user and admin with dot lines. So we also added some additional elements such as rental cancellation, which basically says that if you rent the bike, you can also cancel it. And finally, we add some implementation references to the processes and data stores. For example, there was a data store called available bikes, and we changed it to SQL server available bikes. Or there was data store called user location, and we changed it to a GPS server user location. Also, we added some implementation references to processes. For example, there is managing proof system process, and we basically include, let's say, Python, so we can show how it will be implemented in code. That was all. It was all about my part.
Now I will talk about low fidelity design. Here we actually listed our requirements such as user registration, user login, and etc. I will not list them, but you can see from the presentation, we actually, according to this list, we design our prototype, but it is low fidelity design. Here's the pages. First, our application requires login, sign in, sign up. It is quite important. If you cannot actually use our application without signing or signing up. When you select these two options, you will see the second and the third page. And after completing this part, you can now register your card, which is very important because we are online application and the card must be registered. Also, here's the general page. There's map, and you can choose the available bikes, and you can see the price, and then you can select, and then after you select, and the page opens and it writes your location, and then you choose your payment method. For example, you can choose between your cards, and finally you confirm your order. Beside that, you also have pages like my profile and account. This is quite important because you can edit your profile, edit your card info, and of course you can log out from the application. Also, we have saved places, account, history. When you click to account, there's another page, brings you to the last page on the presentation. It is, you can learn about your promotions, you can take support, and you can learn about the program. And then if you want to go back to the my profile page, you can click to my profile. And we have also this newsletter to get feedback from the customers. Also, we kind of design a prototype, high-level prototype in Adobe InDesign. You can see from here, we actually, I would say, colored the previous design. And there's map, and you can select, and you can choose payment, and etc. This is my part. Thank you for watching.
And I will talk about the data structure design of our online bike rental system project. And as you see, the data will be consist of the user registration, review, admin, bikes, payment, rent, and hotline. It's mandatory for users to be registered to the application to use the system, and the data will be consist of username, email, password, phone number, card, and location. It's a one-to-one relationship between registration and user. The user phone number will be used as a contact number between hotline service and user, um, and also will be used for registration. And the card will be used as a payment method, and the location will be used by the device to navigate the user to the bikes, which counts the distance between the user and bicycles. It's one mandatory to many optional relationship between renting and user. The renting system will need the renting number, which is which is a code as a unique number, will be used, and it will use the user ID and renting price and renting duration, and of course the review will be used, which is also one mandatory to many optional, because one user can share many reviews uh, on many optional rentings and many optional reviews. And it's a username, command, and star will be used to review the experience. As a payment, again, the renting ID will be uh, used as a tool. The number, which is a code, is a unique code to rent a bike. The price and user ID also will be part of the payment data. There is a one mandatory and many mandatory, or can be many optional relationship between renting and payment, and one mandatory to many optional relationship between users and payment. There is one there's a many mandatory and one optional relationship between bikes and reviews. The bikes will be consist of the data of their unique code, their location, specifications, their price, their conditions, and of course their reviews. And there's an admin is uh, which adds the bikes to the system, or deletes the bikes from the system if there is a need for that. There's a many optional, and there's many optional to many optional relationship between bikes and admins. Um, and of course the project will provide a hotline service if there is a problem in renting experience, or the user manual is not enough as an informative option. The users and the hotline service, which is a one mandatory to many optional relationship, it will provide an opportunity to contact the support system, uh, which is a great feature uh, to users which are supported by the hotline service uh, to get a aid for their experience. That's it for my part. Thank you.